Okay, we're going to get started. My name is Jeff, and this is my collaborator, Julian, on WANIX, WebAssembly Operating and Development Environment. Let's get into this. So this is actually a project. It's part of a bunch of other projects that I work on as a sort of independent open source developer. It's actually, I think, the first project that I'm actually using WebAssembly. I've been a big fan for a while. I mean, this stuff is pretty obvious, right? WebAssembly, some easy things that we can assert, like it's going to replace major use cases of containers. A less obvious one, some people here, I think, might start to see this, is it'll replace webhooks, which is something that I would, as sort of the pioneer of webhooks, I think it's pretty easy to say that WebAssembly, I've wanted WebAssembly ever since since starting to talk about webhooks. And especially with the component model, I think I'm really excited about WebAssembly becoming a sort of universal software module, right? We've never had that before. We've never had some language agnostic like unit of software. So this project started with the Go playground, and Go is one of the first languages to support compiling to WebAssembly. And so I was a little surprised that the Go playground doesn't actually use WebAssembly. It's sends the code off to the server to be executed, and then it comes back. So at kind of like a hacker party, a mutual friend, kind of how we met, I was putting together a proof of concept of a Go playground based on WebAssembly, and I was surprised at how easy it was to just compile the Go compiler to WebAssembly, which would then let you compile Go code to WebAssembly from the browser, or you could also compile to other platforms because of the cross-compilation. The only thing was that it actually needed a sort of a file system to work, so we created it turns out that Go has all the hooks for implementing a file system even without the WASI stuff. And it worked out pretty nicely. So a lot of my work is inspired by stuff in the past, like Plan9, Smalltalk, Genera, and hopefully some of that will come through here. But by already having a compiler in the browser and a file system, I was not far off from basically a Unix-like environment. So I was kind of interested in exploring that, and that's kind of where WANIX came from. So instead of kind of talking about it, we're just going to get into it and show you. We're going to show you a couple of demos, and the first couple of demos will just kind of give you the basics. This is all online. You can get to it on GitHub. We'll have links at the end. But this first part, Julian's going to give the demo, so give it up for Julian.
Thank you. All right, so here we have a bare bones HTML project, and all you really need to include WANIX are two things, with this bootloader.js file and this kernel.gz file. This kernel.gz file contains some user space binaries that we're going to bundle and use later on in the talk. And to include it, all you do is just add it in a script tag here and then invoke it with this boot WANIX line. And I have a server open running this right now, which I'll go into. And right there, it was setting up a service worker and dropping us into the kernel. And after kernel initializes, it drops us into the shell. And so the shell is UNIX-like. We've got some commands to help you with the file system. Let's do the help command. We'll see more of these commands later. This file system is inspired like Plan9, like Jeff said. It's something I've worked on extensively. So we have some cool features. Like, for example, we have a process.fs in sys/proc. Which shows the currently running processes indexed by their ID. And if I cat that file, that one file, it'll show you the process information that we have for the shell. This is pretty neat. WANIX can, of course, execute WebAssembly. Any Go program that's compiled to Wasm can run in WANIX. And in the future, we will support WASI, so you can use any language of your choice. So here, I'm going to run a command that I've copied here, pasted in, which is fetching a binary from the web. This is Hugo, which is a static site generator. It's a Go static site generator. Let me move this into the command directory. Then I can run this just by doing hugo-h. That's going to spit out the help, just to show you that it's actually executing. This is pretty neat. We can run Go programs in WANIX, but we want to be able to build stuff. So we have this build tool, which leverages the Go compiler. Do build.h. But this you can compile any Go package. So let's make a little hello world program, and use this build tool. So let's make directory hello, cd hello, and then let's use micro, which is another Go program, which is a text editor that we bundled with WANIX. It was in that gz file that I mentioned earlier. Let's open main.go file. Let's add main package, import format. This is very basic Go code. Func main, and then do format dot print line. That's supposed to be capital. Print line. Hello world. Let's save that. Quit. And so this build tool is actually integrated with the kernel. So there's something cool I can do. I can just do hello here. And this command hasn't been compiled yet, but the kernel will recognize that it's a command I'm trying to run. It'll recognize that it's made up of Go source files, and on the fly, build it from scratch and cache it in a sysbin directory. So if I run this again, it won't compile again because it's already been cached. This is pretty neat. Let's make another change to it. Let's reopen it up in micro. And then let's change it to say hello Wasm I. Fun. All right, and then let's run that again. And our caching system is smart, so it can recognize that the source files have changed compared to the actual binary. And then it should build on the fly again and say hello Wasm I. That's pretty neat. So now we have the ability to write and compile and run Go programs in WebAssembly. Have I mentioned yet that this shell is written in Go? So we can do something cool here. If I go to the sys/command directory, which has some system commands, we actually have the shell. Oh, I'm supposed to do that in the root. We actually have the shell source embedded in WANIX, which I can open up in micro. And so this is the source file for the shell. Let's scroll down to that blurb you see, the WANIX blurb. Let's add demo here. We'll save that. And if I reload the page, the kernel, just like any other command, will recognize that the shell needs to be rebuilt. It'll rebuild it from source on the fly. And after it spits out the binary, it'll drop us right back in with our changes. So that's pretty interesting. You can develop the shell from within the WANIX program itself. And for our next example, I'm going to hand it back off to Jeff.
Cool. So you guys have probably seen like a shell in the browser, maybe even a shell in the browser that can run WebAssembly. But you probably haven't seen one that has a compiler built in that can produce new WebAssembly and that can modify itself. So the only thing is that this is in the browser, and what are you going to be doing this in the browser for? So to make this maybe useful, we decided to have the concept of web apps. So there's a couple of web apps that are sort of built in here. And actually, one of them is the terminal. So we're actually in a web app in WANIX already. An app is just an iframe that kind of takes over the whole page. And so if we go into terminal, if we go into sys app terminal, we can see it's just an index.html. We'll take a look at that. And so basically, like any resources loaded in this iframe are pulled from the file system that we have. It's going through the service worker, being pulled from our file system. You can see we're just loading xterm.js, and we're doing kind of like a sys call here to open up a terminal, and then run shell. And the rest of this is just piping data from that command into the terminal. So let's look at a couple of other things here. There's more kind of a traditional example application here. We've got a to-do app. This one has a couple more files. It's got like a model TS and a view.jsx. So that's interesting. We'll come back to that. Let's open this and see what it actually does. So kind of what you would expect. To-do app, yay. And, that's pretty much it. It's a really simple app. When we're in an app, we can pull down the visor to get back to the shell. And let's take a look at some of the source here. We've got some TypeScript here, it seems. And sure enough, we've got an interface defined. We've got a class member with some type data. So that's interesting. Maybe we're compiling this on the fly with Babel on the page. No, there's no Babel here. We're actually just importing the file directly. How's that work? Well, the service worker is basically just talking to a Go gateway that's pulling from the file system. And because we now have ES-build, which is written in Go, we can just kind of transpile TypeScript and JSX into JavaScript on the fly incredibly fast. So it's just kind of a nice developer experience for that sort of thing. We could also make a change here. Maybe we'll make the background yellow, and we'll save that. You can see it reloaded the application. The file system has file watching capabilities, and whenever you open an application, it's going to watch the source for it. And if the source changes, it reloads the app. So you've got live reloading, you've got TypeScript, you've got JSX, and there's no Node.js here, which is great, honestly, to be honest. And by the way, this is not a VM, right? Just want to point that out. This is just all running in the browser in WebAssembly from those 2 files that we imported. So let's see, what else are we going to do here? Let's look at another application, because we can build apps, but what for? Well, we can make demo to-do apps. We also make more apps that kind of extend the environment, right? The terminal is a built-in one. Let's look at another built-in one called Explorer. So this app is also really simple. It's kind of modeled after Pros.io, if any of you remember Pros. But it lets us navigate the file system. And this is all it's doing is file system operations against this file system in WANIX. So we go and edit files here. Make it blue. And hit save. And now if we go back and open to do, we've got a blue background. Okay, so what are we going to do with this? One thing that we could do is export these applications. And the reason why that's really interesting to demonstrate is because we're taking advantage of the fact that the Go compiler can cross-compile. So we can actually compile a native binary in this environment, in the browser. We've got a little tool called Export App. And we'll point it to the To-Do app. So what this is going to do is take our simple web application, those couple of files, and embed it in a Go program that just serves them with a built-in HTTP server. And so this is building them, and then once it gives us a binary, it'll just let us download it. So we'll put this in our downloads. And now we'll go and run it. First we'll chmod it and dequarantine it. But now in my native Darwin, environment on this host computer, we can run this binary that we made in the browser. We made a little web server, so let's check that out. It's our app. Yeah. So that's cool. I mean, you could do this. You could compile to Linux, put it in a container. You could, really doesn't have to be a web app. It could be anything that you build in there. So that kind of covers the basics of WANIX, what we released in the 0.1 release not too long ago. And so these next demos are actually going to be more of more real-world use cases. That'll be a preview of our 0.2 release that's coming up. Actually, any questions really quick, like any immediate questions you want to shout out? Because I'm just showing a lot of stuff here. You can also ask in that application that I'm sure none of you installed, but I will get to them at the end. So for this next demo, Julian's going to take over.
All right. So our first example is actually the WANIX website itself. So we have a website set up here at wanix.sh. You can see Jeff's previous talk here. It's got a little features blurb, quick start, some documentation, all the good stuff. But in this bottom right-hand corner, we have this little widget here, which will take us to an admin page.
Have any of you seen the net?
And so this admin page actually uses an authenticator. In this case, it's Auth0. You can bring your own authentication. It doesn't have to be Auth0 specifically. But let's sign in with GitHub. And this is going to take a minute to authenticate. In this case, we're actually downloading that kernel binary from the web. It's not in our little server environment. So it's going to take a little bit of time, but it just gives you more time to admire our loading screens. We worked really hard on that. So here we are. Here we are in the environment again. If I ls, you'll see we have a new directory called repo. So this is another file system feature, actually, that I worked on. This is a custom file system that's mounted in the root that integrates with GitHub's REST API. So any read and write request, or any read and write operation in the file system corresponds to a read and write request to GitHub's REST API. So you can manipulate a remote repository from inside WANIX. So if I ls into the repo, you can see there's two directories here, and these correspond to branches of this repository. And this repository is actually our WANIX site, which is built using GitHub Pages, deployed using GitHub. And so there's the GitHub Pages branch here, and then there's the main branch, which contains our source for the website. We use a static site generator. So let's explore this using our Explorer. Let's go into repo, GitHub Pages, and let's open up the index.html. And remember, this Explorer is just doing file system operations. The heavy lifting is the actual custom file system. And let's make a change here. It seems like demo is already here, but let's redo that. Save it.
Do a demo Wasm.
Demo Wasm.
Yeah. Something like that.
All right, let's save that. And on the right here, you should see it doing a put request. There we go. And so now it's made a commit of our changes to the remote GitHub branch. And that's going to take a minute to deploy to the actual site. So I'm going to show you something else. Let me open up the visor and navigate to repo/main. And so like I said, we use a static site generator to generate the site. We actually use Hugo, and like I showed before, we can run Hugo in WANIX. And now I want to clarify that this doesn't actually work yet, but it's in our roadmap. But we'd like you to be able to run Hugo and point it at the GitHub Pages branch. GitHub Pages. And what this would do is Hugo would read in through the file system the contents of the main branch. It would do the static site generation and then deposit the actual static site in the GitHub Pages branch. So you could develop your website from within your website, which is kind of crazy. I haven't seen that before. It doesn't quite work yet now. We have a little bit of kinks to work out, but it's on our roadmap. So I invite you to come to our next talk. We'll probably show that off. So by now, our changes should have been deployed. So let's go back to the main website. And now we have our changes here. Demo Wasm IO. Yeah, so like I said, we've just edited our website from within our website. We have edited locally and then pushed it to our main deployment branch. Yeah, so that's very interesting, and I'm going to pass it back off to Jeff. Show our next example.
Cool. So yeah, that's pretty cool. A static website that can modify itself. Let's see, what else are we going to show here? So we can show another application, this time an actual WANIX application that's on a domain. And I don't know if any of you have your laptops out, but you could go to io24.wanix.sh. You'll have to authenticate, and it'll take a little bit longer than this one here, just to go through all the steps to get authenticated. And you won't end up in the same session as us, but you can play around with it. So this environment is actually set up a little bit different. So when the shell loads, you'll see very briefly, it has kind of like an auto-run script. And then it's going to go into a new application. So it looks like the to-do app application. Except, and that should be my username, but there's an ID there because we've authenticated, so I have identity here. And actually, if I were to click this link, it'll magically paste it into this other computer, and Julian can sign in over there and see if he can join me in this little app demo. So how many of you are familiar with CRDTs?
You got one over there, 2, 3?
Couple, yeah. All right, so CRDTs, there's going to be a lot of these kind of sync engines, which are basically storing data on the edge in the browser. And the data is stored in a special data type that can be replicated across time and out of order and still end up in a consistent state. And so this technology is going to be used a lot for local first applications, but it lets you do a lot of cool stuff where, for example, well, we can do real-time collaboration. and you can actually go offline and continue to make changes, and then come back online, and it'll all sync up with everything. So it's a really cool technology. We're using Jazz tools for this one, but there's a bunch: auto merge, YJS, and so this is pretty cool. Let's see. So I guess we've turned this into a little chat application. So for this next part, do you want to share your screen so we can see what you're doing? Let's wait for this to pop up.
There we go.
So I'm going to go in here. You've probably seen, like, real-time collaborative apps before. Nothing new, right? This is running in WANIX, but who cares? One of the things that we can do that you probably have not seen before is implement a CRDT-based file system. So we actually have one that's mounted here in GRP. And there's nothing in there but an app. But Julian could go in there because we're in the same session. And you could put a file in there. And let me check this out. Wow, his file showed up. What's in it? I mean, we know what's in it, but there we go. Isn't that crazy? It's like we both SSH'd into a shared server, only there's no server. This is just in the browser, right? Isn't that crazy? So I don't know if you noticed this, but there's an app directory. And this app directory is the application that we're in. So I wonder, Julian, you want to change the source?
Totally. Let's open the Explorer. Let me navigate to the application. And let's make another change here. Let's change the color. Let's make it something fun like purple. I'll save that.
So it's writing to the file system there, replicated to my file system. The application sees a file change, and it reloaded. So what just happened here? He just changed the source of an application that we're using together in real time. He live edited the application. So I don't know if you noticed, that's sort of a theme of what's going on here. It's one of the ideas that we're kind of exploring with WANIX. So let me just show you a couple more things in the slides. I'll talk about the future. What's next? Where are we going? Why are we doing this? Well, one of the things that we tried to do before this talk, but we didn't quite get there, is get VS Code to run in this environment. And you've probably seen VS Code run in the browser before. It's not, everybody's doing that. But it's usually just the front end. We actually got the back end to run in the browser as well in a Wasm VM, which of course was incredibly too slow for it to actually be usable. But we did serve it, that it's an iframe serving from a server running in a VM in WebAssembly in the browser through Service Worker. Also supports WebSockets, which Service Worker doesn't support. How did we do that?
Blood, sweat, and tears.
Yeah, exactly. But coming soon, we'll have that, so it's integrated, and you can run VS Code in this environment, and you can do all these cool live editing changes. You can have it embedded with the app that you're using. So as a kind of a real use case, about a year ago, we worked on an application called Treehouse, which was a kind of an open source clone of Tana, which is a Notion-like tool. So you can do basic note-taking stuff, but it's got structured data and different views, and the user can kind of modify it. And so we're going to come back to that and basically introduce CRDTs. And so, as you saw, it's really easy to make things communicative, make chat apps and stuff. So we're basically thinking of turning that into a sort of Discord-like tool. And so Discord and Slack are kind of the operating systems of teams and organizations these days. So wouldn't it be cool if you could modify your operating system for your team, for your community? And so you can imagine, it's almost like BBSs back in the day where they're all different, they're all really interesting, except these BBSs are ones that you can collaboratively modify. And so maybe you and your friends decide, let's make a game together. And then you make a multiplayer game within that environment, and only your community has this. So that's the kind of stuff that we're working on, and this is all open source. There's no company, there's no funding. I mean, I'm paying for this, but so if you want, you could support this. If you want to get to links or get updates on any of these cool projects, you can go to this link here. But that's it. What do you guys think? Do you have any questions? We can look at this app, see if anybody's submitted anything.
One question over here.
Yeah.
How big is your team to do all of this?
You're looking at it.
Yeah. And Tara. We have
And Tara, yes.
Project manager. We also do other projects as well. So, yeah. I mean, a lot of it's. Yeah, I do a lot of open source projects, and it's a lot of work. If any of you are interested in helping out and contributing, I'd be very happy.
Thank you for the talk. It was awesome. The demos were great. I've seen your previous talk, so it's great to see the progress. My question was going to be, and you kind of alluded to it with the WebSockets. How does networking fit into this, and kind of if you can talk a little bit about the challenges of, because that's, to me, that's kind of like the only missing piece to make this like really like a VM on the browser.
Yeah, I've been exploring that. So far, the only networking is being able to serve requests through the service worker, and then from there I can kind of route it to whatever. But it would be really great if you could run a Go server in this environment, which actually is not that hard. The Go, the runtime for JavaScript, when you compile to Wasm, for testing purposes, their socket API all works. It just kind of only works locally, but that's perfect. So we can actually expose that to applications and give you a kind of a socket API to listen, create servers to listen on and stuff. But then, of course, you want to connect to remote users in this sort of situation, which we can also do using WebRTC. We've got some prototypes of that and build a kind of a virtual network with other users. In fact, I'd like to, at some point, get to playing Doom networked in this environment. So, yeah, good question. Thank you. Anything else?
Yeah, in the back here. Hey, Jeff.
Hey.
I know you talked about and tried running other compilers to support other language development inside the WANIX environment.
Yeah.
A lot of the compilers don't work out of the box just inside the browser. But have you tried running the compiler inside the VM inside the browser, or is that just going to be way too slow?
It'll be way too slow. I definitely tried that. Anything else? Awesome. Well, excellent audience. Thanks for coming out.
Thank you so much.
And we'll see you around.